Hello all, myself Harshil Gupta and I am a system engineer at Nexus NG Consults Private Limited, and today we are going to discuss about the automated inverter testing that we have developed. So the key points that we are going to discuss are the basics of inverter, the inverter tests that we have performed, the development of our automatic inverter tester, and the inverter testing software. So let's begin. So, what is an inverter? An inverter is a device that converts a DC supply to an AC supply, and it also converts an AC supply to DC. So, if an AC input is given to an inverter, so the battery attached to the inverter gets charged because the inverter converts that AC input to DC output, as well as when the AC input is not given to the inverter, the DC output of the battery gets converted to AC and it is given at the output of the inverter. So that's how it converts DC supply to AC and vice versa. So if you have seen in an inverter, there are terminals for connecting the DC battery. There are also terminals present for connecting the AC input supply. But nowadays, in some inverters, there are also third type of connectors present for connecting the PV panels. So, if you have PV panels at your home, so you can use them to power your inverter. So, this is the basic inverter representation. As we all know, a battery is connected to the inverter, an AC input supply is connected to the inverter, and now a solar DC supply is also connected to an inverter. So these are the various inverter modes as we all know. The mains mode, the charging mode, the eco mode, the UPS mode, the low battery mode and the overload mode. Next, we are going to see some typical tests that can be performed on an inverter. These tests can vary according to the need of our customers. So some of the tests are the no load test, the battery low voltage shutdown test, the boost start and battery charging current test, the low voltage and high voltage cutoff test, the overload shutdown test, the rated load test, and the solar inspection test. So we are going to discuss each and one of them in detail one by one. So let's begin. So in a no load test, a DC supply is applied to an inverter, and after applying the DC supply, what we have to do is we have to just switch on the inverter, and after that we have to measure the output voltage of an inverter, the output frequency of an inverter, as well as the current drawn by an inverter from the battery at no load. Next, the battery low voltage shutdown test. In a battery low voltage shutdown test, what we are going to do is we will going to decrease the battery voltage across the inverter step by step. And as you know, when the battery is in discharging mode, the voltage across this terminal continuously decreases with the passage of time. And when and there will be a time at which the inverter will going to give you an alarm of low battery, and after that it will going to shut down, means the output of the inverter will become zero. So we are checking that condition in this test. So first of all, we will be decreasing the DC battery voltage step by step, and we have to measure the voltage at that step at which the inverter will go to shut down and its output will become zero. Next, the boost start and battery charging current test. If you have seen in an inverter, when the AC input is given to the inverter, the battery which was earlier in discharging mode now goes into charging mode. So for that to happen, a same polarity voltage appears across the battery terminals from the inverter side, and this voltage is slightly higher than the rating of the battery itself. So this sudden increase or a slight increase in voltage is known as the boost start voltage. So we have to measure that voltage, as well as we have to measure one another parameter, that is the battery charging current. So at the time of charging, the battery will going to draw some current from the inverter. So that current is known as the battery charging current. So after taking these two readings, our test will get concluded. Next, what we are going to see is the low voltage and high voltage cutoff test. In a low voltage and high voltage cutoff test, what we are going to do is we will going to decrease and increase the AC input voltage step by step. So if you have seen in an inverter, when the AC input is very low, you have seen that the inverter, in spite of getting AC input, gets shift to the battery. As well as when the AC input is very high, then also you have seen that the inverter does not stop sensing the AC and will get shifted to the DC battery. So you can say that the inverter operates within certain limits of AC input voltage, or it recognizes the AC input within certain range. And if the AC input gets below that limit, or if that AC input crosses that limit, or it becomes higher than that limit, then the inverter will stop sensing the AC will get shipped to the battery. So in this test, we are checking the lowermost value of this AC input and the highermost value of that AC input. So for that we are decreasing, first we are decreasing the AC input voltage step by step from a certain value, and we are taking the reading at that step at which the inverter will shift to the battery. And for checking the higher limit, what we are going to do is we will increase the AC input voltage from a certain value step by step, and we will be taking reading at that step at which the inverter will shift to the battery. So after taking these two limit values, the test will get concluded. Next, the overload shutdown test. As the name suggests, we will be operating the inverter under overload. So we will be overloading the inverter by applying a load which is greater than the rated load. So what we have to do is we have to measure the output voltage of an inverter at overload, and we also have to take the reading or measure the current run by the inverter from the battery at overload. So ideally at overload you have seen that the inverter goes to shutdown. So ideally the output of the inverter should be 0. Next, the rated load test. As the name suggests, we in this test we are going to operate the inverter at rated load, and again we have to measure the output voltage of the inverter as well as the current drawn by the inverter at the rated load. Next, the solar inspection test. As we know, in a solar inspection test, we will be applying the solar DC supply to the inverter, and the inverter on which was earlier on the on the discharging mode now comes to the will shift to the solar supply, and it will going to draw power from that. So again, we will be applying a certain load on an inverter, and we will be measuring the output voltage of the inverter as well as the current drawn by the inverter from the solar DC supply. So next we will be discussing about the development of our automatic tester for inverter testing. So if you have understood our test that we have just discussed, so you might be thinking, if we take these general power sources like the DC battery, like the fixed AC input supply or the PV panel, that we cannot perform certain tests so the answer to this question is no, we cannot perform all the tests that I just mentioned. So for performing all these tests, what we have done is we have simulated these general power sources, like we have simulated the DC battery power supply, and we have simulated the solar power supply of PV panels with the help of programmable programmable DC power supplies. And for simulating the AC input supply, we have taken the programmable variable AC power supplies. And we have taken a power meter for taking all our readings. So next, this is how our automatic tester looks like. So there is a DC programmable supply for our battery. There is a power meter. There is an AC programmable supply for AC input. There is an industrial PC. There is a DC programmable supply for solar DC input. Next, this is our inverter testing software. As you can see, all the parameters have been tested, and you can see the reading value is being compared with a certain limit, and if that value lies within that limit, then these tests are passed. If these value does not fall in these limits, then the test will get failed. And the data of these readings will get saved automatically in file suggested by our client. So next we will be discussing about our company Nexus NG Consults. So as you know, Nexus is a startup and is a company established in 2009, and we are the alliance partner of National Instruments. Along with, we have collaborated with so many companies like Tollinger, Schmidt, GaugePack, Roga, Zimmer, and MMF accelerometers and Gauge. So we deal in data acquisition, we deal in complete ATE solutions, we provide vision based systems, we also provide trainings on data acquisition software such as LabVIEW. We also provide solution based on sensors. We also provide LIN and CAN based solutions and systems. We also involve in making software development according to the need of our customers. We also provide data log and monitoring systems. We also involve in RF based systems, and we also provide wireless data acquisition systems to our customers. So, if you have any doubt, any requirement based on these discussion that we have made, and the things that I have just mentioned that we offer, then these are the contact details of our company. Kindly contact us. Thank you.